Hey students, this is lesson 3.5, parallel lines and triangles. We're going to learn how to use parallel line to prove a theorem about triangles and to find the measure of angles in triangles. Go ahead and do this review. I'll check back with you. All right. So first thing we're going to do is look at an important postulate that we need to use to do some of these problems. And that is postulate 3.3, parallel postulate. Through a point not on a line, there is one and only one line parallel to a given line. So we can draw one line through point P parallel to line L. And then theorem 3.10, the triangle angle sum theorem, says that the sum of the measures of the angles of a triangle is 180. And so what we can do to find the missing angle is just take 180 minus the other two angles to get the missing angle. And so this is a 90, so 180 minus 135 is equal to 45. So that's the triangle angle sum. And this is a proof of that uses the other theorem we have there, that you can draw one line through a point. And notice that if we draw a line parallel to AC, we introduce some angles, but those angles are, notice that, so this is now a transversal here. And so our angle 1 is the same as this angle here, because alternate interior angles are congruent. And likewise, if we think of this line as a transversal, then angle 3 is the same as this angle. And so these three angles together make a line, which is 180 degrees, and they're the same as these three angles. So that's where this proof is coming from. You can study it to try and get to know it a little better. But we're going to go ahead and use the triangle angle sum theorem here to figure out some missing measurements. And there's a couple ways you could go about it. You could first try and look for the ones that are missing the least amount. Like maybe let's find this x first in this triangle. So we have x plus 32 plus 46 is equal to 180, and that's by the new theorem, the triangle angle sum theorem. And 32 plus 46, that's 78. And so let's just subtract 78 from both sides. We get x is 102. All right. Now that we know that x is 102, there's a couple ways we can handle this next thing. X and y together are a linear pair, so we know x plus y is equal to 180. And we know x is 102, so we could substitute that in. Then we could just subtract 102 from 180, and we get y is equal to 68. And then we have one left, z, to find. And we know that y plus z plus 36 is equal to 180 in this triangle here. And we now know y is 68. And 68 and 36 is 104. And subtracting 104 from both sides, we get z is equal to 76. So, using the triangle angle sum theorem, we can find all the missing parts. Go ahead, you try that. All right, another theorem we're going to use here is called the triangle exterior angle theorem. And the exterior angle of a polygon is an angle formed by the side and an extension of the adjacent side. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. And the measure of each exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So in this case, the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And you need to know which are the remote angles. So if this is the exterior angle, then 1 and 2 are the remote angles on the interior. 4 is the exterior. 5 and 6 are the remote angles there. And we're going to go ahead and use that idea. It says, what is the measure of angle 1? And the theorem tells us that the measure of angle 1 is just the sum of the remote interior angles. So we can just add these two to get the measure of angle 1. And that's equal to 87. That's pretty easy. But even if you didn't know that, you could figure it out because you have the triangle angle sum theorem. And so 46 and 41 and this missing angle altogether add up to 180. So if you took 180 minus 46 minus 41, you would get the measure of angle. That missing angle is 103. I subtracted that wrong, sorry. That's equal to 93, and then once you know that angle is 93, these two angles together are linear pairs, so they add up to 180, so you could just take 180 minus 93 to get the exterior angle, which is 87. And that's why this idea works. So let's use this idea to find the missing angle, measure of angle 2. The measure of angle 2 plus 53 together add up to the exterior angle, 119. And so the measure of angle 2 is just 119 minus 53, which is equal to 66. I'll let you try that. All right, here's a problem where we're going to apply this idea of the this triangle theorem. So we have the radar tracks an object. The reflection of signals off the ground could result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there is a radar receiver A at an airplane at B, and the airplane's ghost at D. What is the value of X? So how many degrees is this angle right here? And we can use the idea that we found out here that this angle is equal to the sum of the remote interior angles. So we can represent the sum as x plus 30 here. And that's equal to 80. And so x has to equal 50 for that problem. And then similarly for this one, 110 is equal to the sum of the remote interior angles, which is x plus 60. And we can see that 50 would be the right choice for that one. Okay. Applying the triangle angle theorem. I'm going to just let you try that one. See what you get. Okay, that's the end of the lesson. Go ahead and do the lesson check. Be ready to share that next time we meet in class.